Alright, hello everyone. In this video, let's continue in problem number 5 in mass volume problems. So what volume of hydrogen collected over water at 27 degrees Celsius and 97.5 kilopascal is produced by the reaction of 3 grams of zinc metal with excess sulfuric acid? The vapor pressure of water at 27 degrees Celsius is 3.6 kilopascal. So, this is a mass volume problem. It looks like Dalton's law of partial pressure because we have collected over water here and we have a pressure here. So, let's begin. So, in number 5, we have the zinc metal reacts with excess sulfuric acid. So we need to write the balance equation. So from zinc plus sulfuric acid reacts to zinc sulfate plus hydrogen gas. Okay? And that is perfectly balanced. Okay? And when the temperature increased here, pressure decreased, and the volume will increase. So the ratio of temperature, which is T2 over T1, so T2 over T1, and the pressure is P1 over P2. So we have a pressure 1 here. So our pressure 1 here is 11.325 kilopascal, and the pressure 2, which is 97.5 kilopascal here. This is the pressure 2, 97.5 kilopascal. And then we need to minus in the water vapor here, 3.6 kilopascal. We'll have a pressure water vapor is equals to 3.6 kilopascal. So 3.6 kilopascal. And then we have a mass of zinc here. Mass of zinc is 3 grams. Here, 3 grams mass of zinc, which is 3 grams. 3 grams of zinc. And then there's no given now. So we need to find the volume. Alright, solution. So P2 is equals to P ATM minus P water vapor. So we have a pressure 2 here is equals to P ATM is equals to 97.5 kilopascal minus the water vapor, which is 3.6 kilopascal. 3.6 kilopascal. So P2 is equals to 97.5 minus 3.6, which is 93.9 kilopascal. So we have a given temperature here. We have 27 degrees Celsius. So the temperature here, there's a temperature 2. Temperature 2 is 27 degrees Celsius plus 273 Kelvin. And then the temperature 1, which is the standard, which is 273 Kelvin. So equals to 300 Kelvin. So we need to get the volume of hydrogen gas. So volume of hydrogen gas is equals to 3 grams of zinc here. Put first the 3 grams of zinc times the formula mass of zinc. So we forgot the formula. Mass of zinc is equals to 65.38 grams per mole of zinc. Okay, so times 65.38 grams of zinc, and then 1 mole of zinc times the 1 mole of zinc here in the reaction. So 1 mole of zinc, and then 1 mole of hydrogen gas here. So it's 1 mole of hydrogen gas, and then times the 1 mole of hydrogen gas and 22.4 liters of hydrogen gas at STP times the ratio here. The ratio of temperature increases T2 over T1. So the T2 is 300 Kelvin and T1 is 273 Kelvin. So T2 over T1. So 300 Kelvin over 273 Kelvin times the pressure ratio, which is P2 over P1, P1 over P2. So the pressure 1, which is 101.35 kilopascal, and then the pressure 2, which is 93.9 kilopascal. So 93.9 kilopascal. So you need to cancel the grams of zinc, the moles of zinc, and then the moles of hydrogen gas here, and the liters of hydrogen gas. No, it's a left. And the Kelvin is cancel, kilopascal is cancel, and then the left is liters of hydrogen. So volume of hydrogen gas is equals to, so 3 times 65.38 times 22.4 divide 1 times 300 over 273 times 101.325 kilopascal over 93.9, so equals to 1.22 liters of hydrogen gas. So this is your final answer. Alright, that's all. Please like and subscribe.